Good afternoon, everyone, and welcome to my YouTube channel. So here with me, we are doing two questions, very interesting questions on equilibrium. So what does it mean? So when a body is in equilibrium, it simply means to say it's not moving. So we should therefore note that when it's in static equilibrium, the forces that are acting upwards should be equal to the forces that are acting downwards. And also the forces that are acting towards the left should also be equal to the forces that are acting on the right. So looking at this question, what we are going to do is we need to create the x and y plane. So how do we create the x and y plane? So looking at the nature of the first question, we are going to pick the point at which the chords, or rather the strings, meet. So you will realize to say for string C, it's running from the block to this, then we have A is running here, then that is running here. So since they are running at one common point, that is what we are going to pick as our origin, and we are going to draw our x and y plane. So as I was saying, we need to pick one common point. So we have the point that is here. So we have the point that is here. So we have one common point. Then we have our x or y plane. We are going to have something that looks like this. So we have the x coordinates there, the y coordinates like that. Then we are going to see. So if you look at where this mass is, the mass is here. It's pointing downwards, so it is from the center of the origin. So it's here. So we have the mass, which is equal to 15 kg, like that. Then the other thing that we have is we have this one with this vector that is in both the x and y coordinate. So now, for the sake of reference, I'll be redrawing it, though I'm not really redrawing it. So we have something like that. Now we need to know how we are going to be handling angles. So now we have the angle that is here, which is a 47 degrees. Now according to the rules of angles, we know that if we have an angle which is 47 degrees there, automatically we are also going to have an angle of 47 degrees here. Then we have an angle of 28 degrees here. It automatically means that also the angle that is here is 28 degrees. So now the way it shall be, it's actually very simple. So what we are going to do is let us draw more like an imaginary line which should be moving upwards. Because this is a vector, it means that it can be resolved into its components. So we have something like this in dotted lines. So now what we have now is that here we have the angle that is 47. So every time you look at this angle and look opposite, that is the sign. So sign is always the opposite. So meaning to say, if let's say this is my tension number 1, which is the tension in the chords, this is my tension number 1, this one will be T1 sine of 47 degrees Celsius, or degrees, because it is opposite to this side. So we have the force, or rather the tension, moving the rope up. Then whatever is down here, since the cos of the angle is always adjacent, we are going to write the T1, because it's this rope that is causing there to be the tension in the x. We are going to still say T1, but what will change is just the cosine of the angle 47 degrees. So when we resolve that force into its component, we are going to do the same on this other side. So this other side, what we have is we are going to extend like that. Then we have a 28 here, we have a 28 there. So what will be our opposite will actually be, still it will be T. Now let me differentiate this tension and this tension by making this T2. So it shall be T2 since this angle is opposite to this side, I'll say T2 with a sine of 28 degrees. Then the other thing is, looking at this angle is adjacent, or its base is here, I'm going to use cos. That's how we pick. So we are going to have the T2, then the cosine of 28 degrees, like that. So now, when I resolve my diagram into its components, and knowing to say my diagram is in equilibrium, it simply means to say I can now be able to solve it. Now, knowing to say my diagram is made in such a way that it's in static equilibrium, meaning to say when the upward force minus the downward force is equal to what? 0. So that is what I'm going to do. So knowing to say I'll say the summation of f of y should be equal to 0. So all the forces acting upwards or in the y direction should be equal to what? 0. Then I'll get to identify. So knowing that my T1 sine of 47 is moving up, and my T2 sine of 28 is also moving up, I can add those two. So I have what we have is a T2 sine of 28 degrees. So here it's not necessarily more like we can begin with any, since we are adding. Then we have plus the T1, then we have the sine of 47 degrees. So now this one will be balanced by the force that is moving this string down, which is the weight of the block. So the weight of the block will be equal to, so we know that let me just write it here, but we know that the weight is equal to mg, of which our weight should be equal to 15. Now we are told that take gravity as 10, so we are going to multiply by our 10. Then our weight should be equal to what? We have a 150 newtons. So I'm going to say let me just say minus the weight should be equal to 0. So the sum of the upward and the downward should be equal to what? 0, like that. So we have our T2 sine of 28 degrees, then plus T1 the sine of 47 degrees, then minus we have the weight of the block, which is our 150 newtons, should be equal to what? 0. Having come up with that equation, we will identify to say we can make this go the other side. So we have T2 sine of 28 degrees plus T1 sine of 47 degrees should be equal to what? 150, like that, degrees. So we have come up with that equation. Let's also find out what the summation in the x is. So the summation in the x should also be equal to what? 0, like that. Now, which forces are acting in the x? So we have the force that is pulling the diagram to this angle, and another force which is pulling the diagram to this other side. Now, the force, so we can say let me just move it. So we have our T2, cos of 28 degrees, then minus we have our T1 cos of 47 degrees should be equal to what? We have a 0, like that. So this implies that what we have is actually T2 cos of 28 degrees should be equal to what we are calling this. When it's taken that side, we are going to have T1 cos of 47 degrees. So we have come up with that equation. So now we have two pairs of equation. We have the first one and the second one. So this implies that we need to solve the two equations simultaneously. So since we have to solve the two equations simultaneously, we can now be able to more like even evaluate. So what do we have? So let's say I divide my cos of 28 degrees here and my cos of 28 degrees here. What I'll have is T2 should be equal to let me do the needful. So we have the cos of 47, the cos of 47, then divide by what we have is the cos of 28 degrees. So when we divide these two, we are going to have a 0.772 T1. So that is more like what we have, 0.772 T1, like that. So I can now solve the equations simultaneously, just transfer them. So we have this one and this other one. This implies that where there is T2, we can put this value. So we are going to say our T2, so we have this value. Where there is T2, I'm going to put 0.772. We have T1, then times my sine of 28 degrees plus the T1, then we have the sine of 47 degrees should be equal to what? 150 degrees. So our sine of 28 is actually, first we have 0.772 T1, then we have times the sine of 28 gives us a value of 0.4469, then we have plus T1, then the sine of 47 gives us 0.731, which should be equal to 150. So this is T1. Then all we have to do is multiply the two. So when we have 0.772 times 0.469, we are getting a value of 0. We have 36208 T1, then plus we have 0.731. when we multiply T1 should be equal to 150. So let's just add this. Since we have T1, we can add them. So we have plus 0.731. We are going to have a 1.0930868. Then we have T1 should be equal to 150. So dividing this value, 1.09308 over 1.09308, we are going to have our T1 to be equal to 150 divided by the same value. We are going to have a 13.7. Let me just confirm that. So we have 150 divided by, we have 1.09308. So we are going to have a tension of 137.23 newtons. So this, sorry for that. So this is the tension that we have. So our tension number 1 is equal to 137.23. So in the same vein, where we said our tension number 2, if you remember, our tension number 2 is equal to this equation, which is a 0.772 T1. So we need to multiply this value 0.772 by the tension that we have found, which is our 137.23, which should be equal to, so when we multiply this, we have 0.772. So we have a tension of 105.94 newtons, like that. So this is our second tension, like that. Okay, so let's go to the second question. So the second question says, the system in figure 1.1 below is in equilibrium with the spring in the center and the horizontal. Then we are told to say find the free body diagram for each mass, the tension number 1, tension number 2, and tension number 3. Then we are also asked to find the angle theta. So this is how we are going to do it. So our first one requires us to find the free body diagram. So the free body diagram is simply more like a diagram that shows all the forces that are acting on an object as if it is isolated. So the first one, the free body diagram for each mass. So let's look at the free body diagram, for mass number 1, which is our 40 newtons. So the FBD, which is the free body diagram for the mass or the weight, which is equal to what? 40 newtons. So we are going to isolate it and treat it as if it is the only force that is there. So we are going to have the same. So the 3 chords meet at this point. So this will be our point that we are going to use and draw our x-axis, the y-axis, and all that. So we are going to have a straight line like that. Then on the straight line we have the other coordinates like this. Then since we have that, then we have the T1, which is the force going this side. We have the T1, which is the force going this side. Then the other thing that we have is the angle of 35 degrees is here. Then we have the tension number 2. Then the tension number 1 is here. So the tension number 1, tension number 2. Then we have the weight, which is our 40 newtons. So that means that we have drawn our first free body diagram like that. So we have the force 40, we have the x and y. So let's just be able to even make the y and x components. So this one is a vector since it is both in the x and the y direction. So what we can do here is we can do what we did for the other one. Now we must be careful with the angles. So let us, for this problem, strictly use the angle that is at the base of this. So now if you look at this, if this is 35 and this makes an angle of 90, it means 90 minus our 35, which is going to give us a 55 degrees. So if there it's 35, then it's 55 degrees. So let us use this angle. So this angle is opposite to this side. So we are going to say this is the same as our T1. Since this is T1, we have the sine of 55 degrees. Then the other thing is that here we have the base. Since this is the base to 55, we are going to say T1 with the cosine of 55 degrees. So we have our first free body diagram. The free body diagram will really help us even answer the questions. So we are also going to look at the free body diagram for this other mass. So here what we have is, let me just center it. So what we have is we have something like this dotted, then we have something like this. So we have the weight of the block, which is the weight is equal to 50 newtons. Then here what we have is where T2 is. So we have T2 as well here. So T2 is this side. Then we also have a vector of tension, which is our T3. Now they also want us to find the angle in the later time. So let us just use the same angle since they want us to even find it. So here what I'm going to do is I'm going to do it like that. So now the way it is, it's like this. So if you look at this side is the same as this side since these two sides are parallel. So whatever I will have here is the same as what will be here. So now if you look at this theta, it is opposite to this side. So we are going to say on top, if this is T3, on top it will be T3, then we have the sine of the angle theta since it's the opposite. So whatever is opposite is sine. Then here, since this side is adjacent to this angle, I'm going to say this is T3, then the cosine of the angle theta, like that. So now, this implies that whatever I have here is the same as T3 cos of theta, since these sides are the same, and also here I will have T3 then the sine of theta, since this side and this side are the same. So that is my free body diagram. So now, having drawn our free body diagram, we are going to now be able to find tension 1, tension 2, and tension number 3. So my tension number one, what it is going to be is, so the tension number one. So we know from our previous question that if it is in equilibrium, the sum of the forces in the y should be equal to 0. Now here we have this upward force. Considering this free body diagram. So we are going to have our T1 sine of 55 degrees. Then the only force acting downwards is the weight, minus, we are going to say 40 newtons. That's the weight, should be equal to what? 0. So in other words, T1 sine of 55 degrees should be equal to, taking it this side, we have the 40 newtons, then over the sine of 55 degrees over the sine of 55 degrees, like that. Then our T1 should be equal to, we are going to have our 40 divided by, we have the sine of 55 degrees. So what we are going to have is that our T1 should be equal to 48.83 newtons. So it's a force, so it's in newtons. So we have managed to find T1. Now the other thing is that let's now, for the same free body diagram, we are going to say what do we have in the x-axis for this first free body diagram. So if I say my summation in f of x should be equal to what? 0. Now the force acting in the x direction, we have the T1 with a cosine of 55 degrees, minus we have the other force in the x direction, which is our T2, which should be equal to what? 0, like that. So what we are looking for is T2. So I know my T1 is 48.83. So I'll say 48.83 times the cos of 55. Taking this T2 this side, I'll have should be equal to what? T2. So if I multiply the 2, I'll have times the cosine of 55 degrees, I will have T2, which is equal to 28.008 newtons, should be equal to what? Our T2. So our T2 is equal to 28.008 newtons. We are done with the first free body diagram, so let's go to the other free body diagram that we have created. So the second free body diagram, what it is saying is that we have T2. So we are going to say the summation in f of y for this free body diagram should be equal to, 0. So the upward force is T3 cos of theta. So we are going to say T3, then we have the cosine of theta, then minus the downward force, which is my weight, which is equal to 50 newtons, should be equal to what? 0, like that. So this is my equation where I'll say T3 with the cosine of theta should be equal to 50 newtons. So this is my equation. The second equation should be able to come from the x components. So I'll say the summation of the horizontal forces should be equal to what? 0. Then my T3 sine, since the sine is here, T3 sine of theta, then minus T2 should be equal to what? We should have a 0. Now we know to say our T2, according to our previous answer, it's equal to 28.008. So we have T3 sine of theta should be minus, we have 28.008 newtons should be equal to 0. So our T3 sine of theta should be equal to, we have a 28.008 newtons, like that. Then we have two pair of equations which cannot be solved individually. So let me just transfer them. So having two pair of equations, what we are going to do is we are going to divide equation number 2 divide by equation number 1. Why? Because we always put sign on top. So we have the T sine of theta, which is T3 sine of theta, then should be equal to, we have 28.008, like that. We divide by, we have the T3, we have the cos of theta. Here we have the number which is our 50, like that. So we are finding out that this T3 and this T3 divide, then sine over cos gives us what we call the tan of theta should be equal to, when we divide these two, we are getting a 0.56. 0.56. So we are going to say theta should be equal to the tan inverse of 0.56. So when we find the tan inverse of 0.56, we are getting a value which is, our theta should be equal to a 29.26 degrees. So this is the angle that we have. Now with this angle, we can now be able to find what T3 is. So we have our T3 cos of theta should be equal to 50 newtons. This implies that we can just get any equation. This implies that T3 must be equal to 50 newtons over the cos of theta. So we have T3 should be equal to 50 newtons over the cos of the angle, which is our 29.26. So our T3 should be equal to 50 divided by that. So when we divide, we are going to have a 57.3 newtons. So let me just write down the values that we have found. So we have our T1 should be equal to, we found our T1 to be equal to we found our T1 to be 137.23 newtons. We also found our T number 2 to be equal to 105.94. We found also our T number 3 to be equal to 57.3 newtons, and finally our angle theta, which is equal to 29.26 degrees. Thank you very much for watching my video, and I hope you would subscribe and like for more.